So the last piece of the puzzle we'll cover at the moment is to give an overview of SpringWebMVC. Remember, MVC stands for Model View Controller. And SpringWebMVC is a framework that's supported in Spring Boot 2.0, which is what we're using as part of our programming assignment infrastructure, our platform. And as you can see here, it's the part that is built on top of the Servlet API, much like we just talked about in the previous lesson. And it uses synchronous blocking I/O with one request per thread, or one thread per request, depends on how you want to look at it. And you can see there's other stuff here that might be familiar to you if you've done a lot of programming. There's things like servlets, which are these abstractions that handle requests coming in from clients in a web server environment, servlet containers, which is where business logic typically is hosted. Then there's various data repositories like the Java Database Connector, JDBC, or the Java Persistence Architecture, JPA, NoSQL, which is a non-relational style, key value mapping database type approach. So again, this is kind of the stack we're talking about. We are not going to talk about the reactive stack right now. We'll come back and talk about that. For my money, that's where the action is these days. Having said that, it's helpful to understand the other model as well, because a lot of things are based on it, and we haven't covered reactive programming yet. So for the next assignment, you'll be using SpringWebMVC as opposed to SpringWebFlux. And then when we cover reactive programming, then later you'll use SpringWebFlux. So this is kind of exploding in and looking more detail about what's going on here. So it uses the Servlet API, and it uses a synchronous I/O architecture. What does synchronous mean? Synchronous means that the caller blocks while the callee does its thing, and when the results are done, the results come back to the caller, which then unblocks and keeps on doing whatever it's doing. So you can kind of think, I'll give you some example. This is a very simple example. If you call someone on the phone and want to have a conversation with them, then while the phone is ringing, or whatever it's doing, buzzing, you're blocked, waiting for the person to answer. And then once they answer, assuming you're not multitasking while you're talking, you will be engaged in a synchronous conversation where you talk and they talk and you talk and they talk and so on and so forth. That's a synchronous model. In contrast, when you communicate with people through email, it's typically an asynchronous communication. Most people don't, send an email message and then just sit there by their email waiting for a response to come back, right? That would be a little bit wasteful. You're probably better off doing other things like browsing the web or watching YouTube videos or whatnot. So that would be an example of an asynchronous communication. It's not meant to be responded to immediately. You, the sender, the party that's initiating the communication, are not blocked waiting for a response to come back. Whereas synchronous communication, there's blocking going on. And this is particularly important with respect to I/O. So you read to a file, you read a file, you block until you get the contents of the file. You write to a file, you block at least until the data is transferred off into the OS kernel. You send a request, you would block until you get a response, and so on and so forth. And this is basically just a way to visualize this. So each request is handled by a thread that blocks until it's able to fully process the request, or until the request is fully processed. So here's an example. We go ahead and look up in a server. Let's say we have a flights database that we're going to look up flights to find what flights are available to go from, say, here to Pittsburgh this week. And we would send a request. We would wait. We get a response. We send another request. We wait. We get a response. We send another request. We wait. We get a response. And so that's what we think about as synchronous I/O. And the basic idea here is that the client, which is this thread, is blocked. That's my icon for blocking. It's like a blocker in football, or American football. And you can see here that there's a thread that handles this request. There's a thread that handles that request. There's a thread that handles this request. They might be the same thread. They might not be the same thread. It depends on various factors. But the point is that these are what are known as synchronous calls. And this could take a little while to run because the network has some delay. The server might be loaded. The database might be loaded, might be overloaded. And so it may take a while to get back. And that means that the client is blocked until it gets a response back. And of course, you may ask yourself, does it have to be that way? And the answer is no. But that's the way it works with synchronous communication. And that's what we get with SpringWebMVC out of the box. One of the nice things about this model is that it has a natural form of back pressure that keeps the client from sending too many requests to the server that the server can't keep up, because the client isn't sending another request, at least not in that one thread, until it gets a response back. I had a fun experience with this when I was a graduate student in California. My PhD advisor was Japanese, and when I first worked in his lab, I would kind of overhear him talking on the phone because we shared a lab, and he would say, "Hi," a lot. So every few seconds he'd say, "Hi, hi." And at first I thought, this is the friendliest guy. I've never met a guy who's more friendly. He says hi all the time. What a great guy, right? And then it took me a while to realize, I mean, it didn't take me very long to realize, because I asked him, why do you say hi all the time? He said, well, in Japanese, and perhaps other languages too, hi means, I have received the last bit of information you sent me. Please continue. It doesn't mean I understood what you said. It doesn't mean I agree with what you said. It's just a protocol that says, I received it. Keep going, right? And so that's an example of back pressure and flow control and stuff like that. So conceivably, if you're talking to someone who's Japanese and they don't say hi for a while, you may have overrun their buffering resources and they may no longer understand what you're saying, right? So it's just a way to keep things going. So we will talk later, not right now, but when we get into the reactive programming, because that requires some other form of control besides just blocking. You have to have this thing called back pressure or rate control and so on. But with synchronous calls, that's not an issue. Now, there's also a downside to this, and namely, if you want to have things run at the same time, if you want to have multiple requests from a client going to one or more servers at the same time, not just doing this, synchronous request response, fully bracketed, wait, send a request, wait, get a response, send the next request, wait, get the next response. If you don't want the serialization of all that stuff, then you're going to have to start spawning a whole pot of threads on the client in order to be able to have multiple things going on, each of which will block, but all of which could go on at the same time, assuming that you have a multi-threaded environment that supports concurrent processing, assuming you have multi-core processors and all kinds of other good things, or direct memory access that allows communication and computation to overlap. So the downside with a fully synchronous approach is you need a lot of threads to handle, on the client side, sending things in parallel, and on the server side, you may also need a lot of threads in order to handle bursty clients, because there could be a situation where many clients all send requests at the same time. Even though any given client could be synchronous, you could have many clients sending requests. And so as a consequence, you can end up with a lot of threads. And that's the downside with this approach. And that's why the more modern way of doing things is to use reactive programming, which we will get to. But for now, this approach suffices. It's just not the latest and greatest. I will say it's a lot easier to program though. The network communication in SpringWebMVC uses common Java types. And we'll see that you can send across things like strings, you can send across things like integers, and you can also send things that are collections of these things, like lists. So here's some simple examples. You can see here where we have a method called find departure dates, and we pass in the string that corresponds to the departure airport, and we get back a string that we pass in the string for the departure airport, and we pass in a string for the arrival airport. And what we're going to get back here is a list of local date objects. And that's going to tell us the departure dates from that airport to the other airport. And so in this case, we're getting back a list. There's other ways of passing back maps and so on and so forth. When you deal with SpringWebMVC and you make a request like we saw here to get the departure dates, the results come back in one fell swoop. So the parameters that are sent over, which in this case would be a pair of strings, those go over in one HTTP message. And then the result comes back as a list of local dates, or whatever I call those things, local date. That comes back as a single operation. So you get back a list of these things. And that will, of course, be encoded under the hood by default with good old JSON and other representations that use JSON-based encoding. That's okay. However, there's a downside to this, and it's somewhat similar to the downside we talked about before with respect to the synchronous two-way blocking calls. If you have to wait till you get the entire list to send it back, that can increase the latency. And that's because it may take a while to get all the various pieces assembled. You know, if you go out and you query your front-end API gateway, and that then turns around and makes 25 calls to different airline databases, you know, Southwest, American, United. Think about Kayak, or think about Expedia, or any other sort of airplane aggregator. You got to wait till they all come back, kind of like the stateful request we talked about for streams, and then you get that result sent back. And that could mean that you're not as responsive as you might otherwise be. And when we get to reactive programming, you'll see that's one of the benefits of a reactive programming approach. The data can start to be streamed back as soon as the first of it shows up. You don't have to wait for the whole thing to show up. So that's a quick overview of SpringWebMVC. There's a lot more to say about this. We will look at some examples. I will put up some videos that you can look at that'll walk through a really cool client-server program to demonstrate all these things in more detail, but that'll come next.